Hello, students, and welcome to our algebra lesson today. First thing, we need to make a correction. This is the February 11th lesson. We just look a little behind because we had a snow day. We had Skype a scientist, so we're just a little bit behind, but we'll get caught up. So this is the February 11th lesson. So we'll start with our do now, which is where we respond to a prompt about being inclusive. And today we will continue solving systems of linear equations applications. And we're going to talk about the 4 steps again to solving a system of linear equations. And we're going to talk about why is it important to define the variables first when you solve a system of linear equations application. So our assignment will be to do problems 12 through 20. Make sure you answer the do now and the exit in class notebook, and make sure you upload your completed assignment in Teams. All these steps are important. This is where your grade comes from for participation, so make sure you do that. For our exit ticket, we'll answer the question, why is it important to define the variables first when solving a systems of equations application? For homework, I want you to do problems 6 through 12 on homework 5.6, and you know all of the important things that you need to do for success in this class. So if you have not turned in photos of your work, then you can't get credit. So please turn in those photos so I can see what you've been doing and you can get credit. It's like not getting paid for a job well done. Also, we have an interactive notebook assignment in Teams that's due Friday morning. It's only 4 pages, small assignment, lots of points on the report card. Get that done. So for our do now question today, we have when everyone feels included, everyone feels safe and worthy. Does having a safe and inclusive environment help us learn better? Do you think that you can learn better when you're feeling not stressed about being part of a group? When you feel like others include you, when you feel like you're a worthy member of the group, does that help you to learn better? And also, as you're thinking about that, think, what can you do to make others feel included? And I'd like you to write about that here, please. We'll come back to our exit ticket in a few minutes. I think I didn't even put it on there, but we can go back to it. Well, let's take a look at these problems. So first we have the town rec department, which ordered a total of 100 baseball cards and baseballs, and bats for the summer baseball camp. Baseballs cost $4.50 each and bats cost $20. Total purchase was $822. How many of each item was ordered? Start with our X box first. Let X, we're going to have X equal the balls, and we're going to have Y equal the bats. So 100 total, that's our first equation. X plus Y equals 100. And then we know that the baseballs are 450 and the bats are 20. So baseballs are our X and bats are our Y. So we're going to have 4.5x. I'm going to make it an easier decimal to deal with, plus 20y equals $822, because that's the amount of money they spent. So I'm going to solve this. This is a great problem for substitution. So I'm going to go ahead and solve this equation for x, and x will equal negative y plus 100. Now I can take negative y plus 100 and substitute it for x. So let's do that now. So 4.5 negative y plus 100 plus 20y equals 822. Now I will distribute for negative 4.5y plus 450. You should be able to do that without a calculator. plus 20y equals 822. Now we'll combine like terms. 20 minus 4.5 is 15.5y plus 450 equals 822. Subtract 450 from each side, and 15.5y equals 372. And then divide both sides by 15.5, and y equals 24. Okay, so now let's take y and substitute it right here in this first equation. So x plus 24 equals 100. So x equals 76. So what we have are 76, x's are balls. They bought 76 balls and they purchased 24 bats, which makes sense because when you hit those balls out into the woods, sometimes you can't always find them. All right, I'm going to erase where I covered up our second problem so we can go on and do that problem. So this is about, still with the baseball theme, we've got a group of 40 children who attend a baseball game on a field trip. Each child received either a hot dog or a bag of popcorn. Hot dogs were $2.25, and popcorn was $1.75. If the total bill were $83.50, how many hot dogs and how many bags of popcorn were purchased? All right, X box first. So I'm going to let X equal hot dogs, and I'm going to let Y equal chips, or popcorn, excuse me. I like chips better than popcorn, but they got popcorn. And so we know that there were 40 children, so we know that x plus y equals 40. And we know that hot dogs are x is $2.25, popcorn or y is $1.75. So 2.25x plus 1.75y equals this total, $83.50. So I think this is a great one for substitution. I'm going to solve for y. So we'll have y equals negative x plus 40. And I will substitute that for y in this problem. So 2.25x plus 1.75 times the quantity of negative x plus 40 equals $83.50. So now we distribute. So we have 2.25x minus 1.75x plus negative 175 times 40 is a positive 70, or it's positive 175 times 40 is positive 70, equals $83.50. And now we can combine like terms. So 2.25 plus 1.75 equals 0.5x. I'm sorry, this is a negative. Get that right. There we go. That would be 0.5x. Be very careful with that. Subtract 70 from both sides, and 0.5x equals 13.50. Divide both sides by 0.5. Be super careful with your decimal points. And x equals 27. Now the easy part, we're going to substitute 27 for x in the first problem. 27 plus y equals 40. Sorry about my email. And y equals, subtract 27 from 40, you have 13. Okay, so what do we got? 27 hot dogs and 13 bags of popcorn. Or they might have been in a box, I don't know. Bag or box, doesn't matter. There were 13 of them. Okay, let's move on to number 3. One night, a theater sold 548 movie tickets. An adult ticket cost $6.50, and a child ticket cost $3.50. In all, 2,881 was taken in. How many of each ticket were sold? So let x equal the adult tickets. Let y equal the child's ticket. And x plus y equals 548 tickets in all. But the adult ticket was $6.50, so I'm going to make 6.5x plus the child's ticket, which is $3.50, 3.5y equals $2,881. And I'm going to solve the first equation for y. So y equals negative x plus 548. And this is another problem that's really good for substitution because I'm going to substitute that quantity right there for y. So 6.5x plus 3.5, and I'm going to make that substitution, negative x plus 548 equals 2,881. And now we distribute 6.5x minus 3.5x plus 548 times 3.5 is 1,918 equals 2,881. Combine like terms. 6.5 minus 3.5 is 3x. Subtract 1,918 from both sides of this equation, and 3x will equal 963. Divide both sides by 3, and x equals 321. So let's go back to the first equation, and we'll substitute 321 for x, and we subtract 321 from each side of this equation, and y equals 227. So that means there are 321 adult tickets sold and 227 child tickets sold. And that's the answer to that. So let's move on to number 15, a similar problem. Adult tickets for the school musical sold for $3.50, and student tickets sold for $2.50. On a given night, 321 tickets were sold for $937.50. How many of each ticket were sold? I hope you try this on your own before you come back to the video. Well, I'll start with the X box. I'm going to let X equal the adult tickets, and I'm going to let Y equal the child or student, I guess they're called student tickets. So that will be the student tickets. And so my X plus y equals 321. That's the number of tickets sold. And the adult tickets, which are $3.50, so that would be 3.5x plus the child ticket, 2.5y, equals $937.50. So again, this is a great one for substitution. I'm going to solve for y. So I will have y equals negative x plus 321. And I will substitute for y in that second equation. So I will solve for x. 3.5x plus 2.5 times the quantity of negative x plus 321 equals $937.50. Now I distribute 3.5x, and 2.5 times negative x is negative 2.5x. 2.5 times 321 is $802.05, or 50 cents, excuse me, not 5. And that equals 937.5. Combine the x's, 3.5 minus 2.5 is x. So we have x plus 802.5 equals 937.5. Subtract 802.5 from each side, and x equals 135. So that would be how many adult tickets. We'll substitute that into our first equation. 135 plus y equals 321, and y equals 186. So 135 adults attended, and 186 children attended. Okay, now we have a problem about a collector and his dimes and nickels. This will be another substitution problem. So a collection of dimes and nickels is worth $3.30. If there are 42 coins in all, how many of each kind? So we want to know how many dimes and how many nickels. So let's let x equal the dimes, and we'll let y equal nickels. And there's 42 coins in all, so x plus y equals 42. And dimes are worth 10 cents, so 0.10x plus nickels are 5 cents, 0.05y equals, and they said this collection is worth $3.30. So again, this is a really good one for substitution. So I'm going to solve for y, which will equal negative x plus 42. And I'm going to substitute that for y in the second equation, which will give me 0.10x plus 0.05. And there's my substitution. Negative x plus 42 equals 3.30. Now I distribute the 0.05. Remember, it's not 0.5. 0.5 is 50. This is a nickel, 0.05. 0.10x, and positive times the negative, minus 0.05x plus 42 times 0.05 is 2.1. Equals 3.3. Combine like terms. 0.10 minus 0.05 is 0.05x plus 2.1 equals 3.30. Subtract 2.1 from each side. And 0.05x equals 1.2. And then we divide both sides by 0.05. And x equals 24. Now we just insert that for x in the first equation. 24 plus y equals 42, and y equals 18. So there are, x's are dimes. There are 24 dimes and 18 nickels. Okay, move on to the second page. Mary has a collection of quarters and nickels for a total value of $4.90. If she has 42 coins total, how many of each kind are there? So we're going to let x equal nickels, and we're going to let y equal quarters. And we have x plus y equals 42 coins in all equals 42, and 0.05x plus, these are quarters, 0.25y equals $4.90. And I'm going to use substitution. So I'll solve for, I think I'm going to solve for x this time. It'll work either way. So x equals negative y plus 42. And I'll substitute that right there. 0.05 negative y plus 42 plus 0.25y equals $4.90. And now we distribute. So negative 0.05y, and that would be minus 2.10 plus 2.10 plus 0.25y equals $4.90. Let's combine 0.25 and negative 0.05, which will give us 0.2y minus 2.10 equals 490, and we'll add 2.10 to each side, and 0.2y equals 2.8. I'm sorry, we have a plus here, and then we subtract. Okay, so 2y equals 2.8, divide by 0.2, and y equals 14. Now, insert that for y in the first equation, and x equals 28. So we have 28 nickels, and we have 14 quarters. Okay, I think I have time to do, I have a class in a few minutes, so I'm not going to be able to do all of these. These are all substitution though, so let's see how far I get. So Rob has $1.65 in nickels and dimes. He has 25 coins in all. How many of each kind are there? So let's let x equal nickels. Let y equal dimes. And so he's got 25 coins. So we've got nickels are 0.05 and dimes are 0.10, and that's going to equal $1.65. And I'm going to solve for x. And then I'll substitute that right there. Okay, now when I distribute, I'm going to have negative 0.05y plus, so 0.05 times 25 is positive 1.25 plus 0.10y equals $1.65. So I'm going to combine the 0.10y and the negative 0.05y, which will give me positive 0.5y plus $1.25 equals $1.65. Subtract 1.25 from each side. 0.05y equals 0.40, and divide by 0.05 on both sides, and y equals 8. Now we're going to substitute 8 for y in the first equation. And x will equal 17. So that means 17 nickels and 8 dimes. So I think that's all I'm going to get to today with you. I would like you to do number 19 and 20 on your own. Remember, the exit ticket did ask a question. Why is it important to define the variables first when solving a system of equations application? And it's important to define the variables first so that you can keep your work straight, so that you can keep your numbers straight, so that you can organize these problems in a way that you solve them and get the correct answer. You have to keep the information organized, or else you'll mix up your values and you'll have an inaccurate result. So great job today. I'm sorry I didn't get a chance to finish the next 2 problems, but I have a class to teach in a minute. You guys are working really hard. I'm so proud of how you're getting this. Remember, most important, turn in those photos. Every day we're turning into photos. Write to me if you have any questions. Keep working hard, and with practice, you'll be great.